All right, here is your second review for your test coming up right before spring break. So I'm gonna try to go as quickly as I can. And I know that some of you guys are struggling with the first couple problems, so let's take a second to review those. So first one, we're using the Pythagorean theorem, and the Pythagorean theorem is a squared plus b squared equals c squared. Okay, so we're talking about distances there. And so you've got to remember that c is always opposite of that right angle. So that hypotenuse is always opposite of that right angle. So we have x squared is a plus 3 squared is b, and then you have the square root of 15 squared is c. So now it's just a matter of kind of going through and solving for x. So you have we're simplifying at this point, so x squared, there's nothing really you can do with that one, but 3 squared you can simplify to 9, and then, not simplify, but you can work through your problem. And then you have the square root of 15 squared. Well, anytime you square a square root, you're undoing that square root, so it's just 15. And then subtract 9 from both sides, and there's 0. You have x squared by itself now, and now you have 6. 15 minus 9 is 6. Take the square root, and you have x equals the square root of 6. That's it. Okay, so next one, similar. So the hypotenuse again is, or c is always opposite of the right angle. So this one's going to be 7 squared plus 24 squared equals x squared. And we can work through our problem again. So we have 47 squared is 49. Have your calculator ready. You have 24 squared is 576 equals x squared. And then we combine them and we get 49 plus 576 is 625 equals x. Grab your calculator, take the square root of 625, and you get 25 equals x. So 25 times 25 is 625. Okay, so that's your first two problems. Number 3. Okay, there's 3 parts to it. It says rotate point A around the origin. So the origin, remember, is 0, 0. And we want to rotate A around the origin 180 degrees clockwise and label as A prime. Well, if you're rotating 180 degrees, just to let you know, 180 degrees doesn't matter if you go clockwise or counterclockwise. That's kind of nice about 180. But since we are asking to go clockwise, that's going to be in this direction, right? So if it's 180, it's going to have the same slope. So we're going to go up 3 over 3, and then up 3 and over 3, and here's A prime. So you can see how it's still that same distance, right? Like if I go lattice points, so if I go 1, 2, 3, it should be 1, 2, 3. Okay, and so there's A prime. All right, reflect A over the x-axis and label as A prime prime. So we're still working with A, not A prime. So make sure you're working with A, and we're going over the x-axis. So from the x-axis, it's 3 points. So 1, 2, 3. So it should be 3 points above. 1, 2, 3. So here is A prime prime. Okay, and then the last but not least, we are applying the rule x plus 3 and y minus 1 to A, and we're going to label it as A prime prime prime. So we have x on the, we're going to go positive on the x-axis 3 spaces, so 1, 2, 3, and we're going to go negative 1 space on the y. So that's our negative 1 on the y. So positive 3 on the x, negative 1 on the y, and that is A prime prime prime. Okay, so that's number 3. Number 4, describe the translation. And so we're moving, so you can pick a point, and it's going to be the same for any point in our problem today. So we have over 4, and then it's down 3. So we're going to say right 4, and then, or sorry, down 2. Down 2. And that kind of sets us up for our ordered pair, or our rule, which is going to be x is plus 4, so x plus 4, and then y, and if you're going down on the y-axis, that's subtraction, so y minus 2. All right, so next one, it says reflect across the y, reflect across y equals negative 1. Well, y equals negative 1, if you remember correctly, is going through y is -1, and it's a straight line through it. So here's our axis of rotation, or axis of reflection, sorry. And you're rotating it the opposite ways, or you're reflecting it across the line. So if x is one space down, x is one space up, or x prime is one space up. So here's x prime. If v, or is it v or y? Looks like v, so we'll call it a v. So if v is one space away, then it's one space above. So here's v prime. And if w on the other side is 2 spaces away, well, it's 2 spaces away down here. So here's w prime. And then we connect all our dots. And it makes that little funky shape. Boom, there it is. All right. Next one, we're getting into some more rotations. So we have rotate 90 degrees counterclockwise about the origin. Okay, so here's our origin, right? And we're going 90 degrees. So if it's 90 degrees counterclockwise, okay, so that means we're going to go in this direction. So we're going that direction, counterclockwise. And if it's one space away from the origin here, and we want to go 90 degrees the other way, then it should be one space away from the origin here. So here's our M, so that gives us our first point, so M prime. And we know that the rest of it is going to be coming down this way. So you can use the inverse slope if you want. So if you know that the opposite inverse slope, and we can go -4 over +5, and then go +5, or sorry, -5, and then -5 and then -4, and that'll end up with k here. But you can also count the spaces from that axis. So if you take a look at k and go, well, I know that k is 4 away from the axis, and I know if I'm turning this, then I can also get that 4 spaces away from this axis. Okay? And so if it's 4 spaces here, it should be 4 spaces there. And so that's going to be your k prime. Same thing with this. I know it's hitting on the axis here, on my y-axis, so it should be hitting on the x-axis here, 2 spaces, right? 2 spaces away from the origin. And then I should be 4 spaces down, so 1, 2, 3, 4. And here is j prime. And then I have L prime, so L prime should be it's going from K, right? And it's going straight this way, so it should be going straight up when I rotate it 90 degrees. So here's L prime. And then just finish connecting all your dots. And there you go. So on the test, I am going to give you guys these little sheets, okay? And you'll have a whiteboard pen. So if you're really still struggling with this, oh wait, I did do that wrong. Your origin should be here, sorry, or up here. There you go. Sorry, my bad. So if you're really struggling with this on the test, like apparently I am, something did not look right. It should be up this way. There we go. And you can always, we're going to rotate it around that origin. Okay, so you can always rotate it with this if you're really struggling with it, how to do it. And we're going counterclockwise 90 degrees. I'm okay with you using the clear sheet on the test. So I'll give you guys a chance to have those, and we'll practice with it before the test too, okay? All right, so up next, we have use the line below for each of the following. Okay, so it says write the equation of the line. Okay, well, the things that you need to know for the equation of the line are your slope. So we're going to start at our lattice points, and I'm going to go up until I see another lattice point. Oh, right there. Okay, and so it's positive 1, 2, 3, 4, and negative 1, 2, 3. So we have 4 over negative 3x, and it's crossing the y-axis at negative 1, so minus 1. All right. Draw the parallel line to the given line, then write the equation of the parallel line to the given line. Okay, so we're going to go up here, and we're going to pick another line, okay? And we just got to make sure that we keep our same slope. So if I'm picking positive 3, and I go up 4, I'm off the map. So why don't we go down 4 and then negative 3, and that should still be the same slope. You can also just say, well, I'm going to move my spaces over the same distance here and here, and I'll end up with the same slope. And so we're gonna go, there we go. Okay, and so our new line has the same exact slope. and it has a new y-intercept of positive 3. Okay. All right, our next one, it says name the two transformations that would move the pre-image to the image. So I'm giving you kind of different steps here. So this is the first one, right? This is the pre-image. Here's your first step, and then here's your second step. Okay, so we're going from here all the way down to here. So the first thing that we're doing is you could either say that it was a shift from here to here, or you could say that it was a reflection from here to here. I'm going to call it a reflection, and I'm going to call it a reflection over the y-axis. And then again, a reflection. The second one is definitely a reflection over the x-axis. Okay, so in the home stretch here, the only thing that I could see differently for the first step would be I could see somebody making the argument that this is a translation, but then you would have to say that it's a translation. So you could say or translation, and it would be x minus, well, 1, 2, 3, 4, 5, 6, 7, 8 minus 8, and y stays the same. So a translation. So I would accept either this or this for the first step, but this step absolutely has to be a reflection over the x-axis. Okay, so we're on to our next steps. And number 9, what is the equation of the line for the reflection point that reflects B onto B prime? Okay, so if we connect B prime and B, okay, we can count our steps here. We have up 1 and then over 4. So our slope between B and B prime is 1 over 4. And we know that a line of reflection has the perpendicular slope. We have talked a ton about perpendicular slope, okay? So perpendicular slopes are, you flip it and you change the sign. So it's the opposite reciprocal. So the line of reflection is definitely going to have a negative 4x. And then the question is, what's the y-intercept going to end up being? Well, if we take our line of reflection and we have the opposite, or we have the perpendicular slope, we can now go negative 4, so 1, 2, 3, 4, and over 1. And then we draw our line. And we have 1, 2, 3, 4, and we draw our line. And this one actually, I just noticed it. I should have noticed it earlier. The y-intercept is already given to us on our line, and that is actually going to be negative 1.5. Okay, so it's halfway in between negative 1 and negative 2. Well, halfway in between is negative 1.5. Okay. All right, on the provided rhombus, one of my favorite math words. Draw the lines of reflection for which the quadrilateral will reflect onto itself. Okay, so that's going to be across. It's going to be down. So we can look at either of these lines and we can flip it over, and it's going to be it's going to reflect onto itself, or sideways, it's going to reflect onto itself. So if you're not really seeing that yet, let's draw that real quick. And on our little clear sheet, you can do this on the test since you'll have a clear sheet. You can always, if you can flip it over and it matches up, then you know your line of reflection is running down the middle. Or if you can flip it over sideways like this, you know your line of reflection is running down the middle. Okay, now it says draw two quadrilaterals for which the diagonals are lines of symmetry. Okay, so I need two quadrilaterals for which the diagonals are lines of symmetry. And so the second part of this problem, I need two quadrilaterals for which the diagonals are not lines of symmetry. So there's two parts to this problem. So it's kind of hiding in there. You got to be careful that you're reading this question carefully. Yes, you're in math class and you're going to be required to read. So the first thing I'm going to do is diagonals with lines of symmetry. So I'm going to call this number 1 and I'm going to call this number 2. Okay, so The first one, the diagonals are the lines of symmetry. Well, you just drew one up here, right? You know that a rhombus has a diagonal, has two diagonals that have lines of symmetry. They are diagonals, they're connecting the corners and connecting the corners. So one of your answers for this particular problem is right up there. And so we have number one is a rhombus. Okay. And that is going to be, we'll just copy that picture up there. And we can connect our lines. Okay, we have lines of symmetry that are diagonals. And then the second one, because I want two, right? The second one, let's draw a kite. Okay, so we have a kite. And you have your diagonal that is also a line of symmetry right there. Okay, so that's number two. All right, so now the second one. So we got number one done, right? So the second one is two quadrilaterals for which the diagonals are not lines of symmetry. Okay, so two quadrilaterals that are not lines of symmetry. So the two that I can think of is the first one. Let's go with a rectangle. Okay, so let's go rectangle. And our diagonals, that is not a line of symmetry. And then I have our, then I have the two lines of symmetry that are, like I said, are not diagonal. So that gives our nice example right there. All right, and our last one, why don't we draw a quadrilateral? Okay, so a quadrilateral actually has no lines of symmetry. Well, it can have no lines of symmetry. So a quadrilateral, and we can make any type of funky shape we want. And that one is not going to have a diagonal that is a line of symmetry. Okay, so here's our diagonals. And guess what? There's no lines of symmetry on this one. So you're good. All right, good luck with your tests.